Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's scribblecast of organic chemistry lectures and solutions to homework problems. In this homework problem, you are asked to name a molecule and draw a 3D structure of the provided name of a molecule as well. The molecules are based on the bicycloalkane nomenclature we covered last lecture. Let's begin with the name of the molecule. The molecule of bicyclic alkane is drawn here, and what we have to do is find the connections to the bridgehead carbons. Here are our two bridgehead carbons, and we're interested in finding the bridges. Now we must number along the longest bridge first, but there are two ways we could possibly number. I'm going to start with black. We could number 1, 2, 3, 4, 5, 6, 7, and go around that way. Or we could number around the longest bridge again, 1, 2, 3, 4, 5, 6, 7. Which numbering scheme is the better numbering scheme? In this case, it is the red numbering scheme because we want to give the lowest possible number to the highest priority group. And the highest priority group in this case is a ketone. The enone will be put in the root, but the chlorines come out front as a substituent. And so what we have here is a 7,7-dichloro. Now, when naming bicyclics, you begin with the prefix bicyclo. So after you name your substituents, you put bicyclo. You use square brackets and you put the numbers for all three bridges between the bridgeheads. Well, we've got a 3-carbon bridge. There's a 3. We've got a 2-carbon bridge. And then we have a 0-carbon bridge. Now we can finish off with our name. We have 7 carbons, so this is a heptane, a heptene, a heptenone. And our heptene comes at carbon 3. 1, 2, 3. We get a hept 3 ene, and then a 6 one. We have to have such a high number for the one because we are required to number through the 3-carbon bridge before we can number the 2-carbon bridge. So there you have it. 7,7-dichloro bicyclo 3,2,0 hep 3 ene 6 one. Okay. The second question states draw a 3D structure of 2-hydroxy bicyclo 3,2,1 oct 6 ene 8 one. We begin by focusing on the bicyclo 3,2,1. That tells us the number of carbons in the bridges. So I can draw my bridgeheads, if you like. And the first one is 3. There's 1 carbon in the bridge. 2, 3. Okay. Now the next bridge has only 2 carbons in it. There we go. And lastly, you notice you usually draw in 3D the smaller bridge number at the top. There we go. Let's fix that. Okay. So I'll put dots at the bridgeheads. And there we go. Now, how do we number? Well, we can number from either side, but if I number from the back, 1, 2, 3, 4, 5, I number through the biggest bridge, then this will be a 6, this will be a 7, and that'll be an 8. This numbering scheme tells me where to put my bonds. At carbon 6, there is a double bond for the ene. Carbon 8, I have a ketone. So I'm going to have to make this a smaller bridge so I have room for the double bond. So there's the double bond O. And then I have a 2-hydroxy. So off of here, carbon 2, I have an OH. So I can rub out my numbers. And there is my molecule. Nice 3D model. Let's try drawing it a little neater. Maybe a little bigger. And I have a double bond O. No OH here. So there would be a 3D drawing. Both these molecules are the same. There we go. And I'll put dots so you can see the carbons, the bridgehead carbons. All right. So that's how you actually can generate the structure. The key to drawing the structure was the bicyclo 321. Notice there are 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. And so it is an oct molecule, an octane-based molecule. And hydroxy appeared at carbon 2. Right. There you have it. Some practicing in the nomenclature of bicycloalkanes and substituted alkanes. I'm Dr. Brian Lloyd. This is my Scribblecast lecture.